Um, I'm not sure what the audience is. Are you guys mostly beginners, advanced? Because I think there's a mix of the two here. Um, this is going to be a little abstract in the sense that we're not going to talk about code especially, but how to structure code so you can share it and make packages. And then import them with a package manager called Vessel. So that's what we're going to do today. All right, a lot of intermediates. Should be fairly simple to follow. It's 6:05 for me here. So I guess 30 people here. We can get started. Um, so let me explain a little bit about what I'm going to talk about today. So you've been writing Motoko the past few days. Um, and probably mostly you work all in one file. But to keep things clean, you kind of want to make modules. And those modules you can put together in packages. And those packages you can share with your friends or put on GitHub for others to use. So Dfinity has a package manager called Vessel, which we're going to look at the end of the talk. So how the talk is structured is I'm going to show you some very boring slides just to sketch some important stuff. And then I will jump into the terminal and we will try to import an existing Vessel package and see how that all works. So I can get started. So talk. First, very quickly about myself. I'm a full time blockchain developer. So this is my job. I started full time on writing Motoko, starting Genesis. Before that, I did some research and reading on the Internet Computer also. Here are some links, my GitHub, Twitter, Discord. Even my messages are open on Discord. I don't respond to spam, but if you have an honest question, I probably will answer it. So yeah, nothing interesting there. But if you'd like, you can look it up. Okay, to get started, modules. So I'm going to talk about modules are one file. A collection of code which you can export. So a module is just a file basically. And Motoko provides you two keywords you can relate to modules, which is the module keyword, of course, and then import. So import you're using to import files. If we look at the first case, you can import relative modules, which are locally. So for example, you have module A and module B, you can import one in another. In this case, we have a file named counter.mo and we just import it. Another case is you probably all have used the base package already the past few days. And so another one is importing from a package itself. So how you can see the difference, it's basically, it starts with mo and then hyphens, and then the name of the package, and then the name of the module you're importing. Very recently, Motoko version 0.6.21, I think, added selective import, which means in online 4, you can see we import the whole module under the name result. But right now you can do selective import. So let's say in the array module, there are function exported named map find, and also fold left, which we can even rename to fold to use internally. So this is basically how you import stuff. Now, how we create a module or a package. Well, creating a module is fairly simple. So you start your file with just the module keyword, and then you put in there your functions and classes and whatever you want to export. In this case, I wrote a simple file called net.mo, and I made a function that returns the min and max of a function. Now, there is one important step you need to understand here, is that since not all of you guys are familiar with programming in a broad sense, is that you can have public and private fields. So what does it mean is the keyword here at the front. So private would mean that you can only access that function, see that function within the enclosing object, module or actor. So in the example case, it is a module. So if that would be private, I can only use it in other functions that are defined within this module. Public. So public is the keyword you want to use if you want to share a module. So most of the time, this will be the case. And so this just extends whatever private means with an additional option to exit this externally. So we're going to make use of this to create our packages and export our modules this way. System is another keyword, but we're not going to go into this. So this is basically used for your pre-upgrades, post-upgrades, and heartbeat functions, which are only available in actors. But that's for another talk. I'm not going to cover it in this one. So when I first started creating modules a long time ago by now, I did it the first way. So I called this the bad example. So basically, Motoko doesn't say how your project should be structured, right? If you do dfx init, it will provide you with a source folder, which is nice. That's how we should do it. But if you're only writing Motoko, maybe you're thinking, I'll just define my function on the root level of the project. But this is, in sense of Motoko, it doesn't matter. But for Vessel, the package manager we're going to use later, this is a big deal. So on the source level, I would not recommend to do it. Just learn and do it by default. Do it at the second level in a source directory itself. Yeah, what's this? So in the previous slide, this is, the encoding of lesser than. It's a bug in my presentation. So it's just if x is less than y, you return x, otherwise you return y. Yeah, that's a question out of chat, no problem. So basically I was saying, make sure to define it in the source directory, since Vessel requires this, and if you don't do it, you won't be able to import it in Vessel. Now, maybe you're thinking, yeah, okay, but what's that int? What does it, is it a folder? So net.mo is clear, it's a file, right? Now the int part, it's another way how Vessel enforces basically how you can structure modules. So int in this case is a directory, and lib.mo is the file that is going to be assumed that's imported. So if we go back to here, so counter can be either counter.mo as a file or a directory, which is named counter, spelled with a capital C, of course. And then in there, you put lib.mo. This is another way of doing it. There is no better or worse. It's a matter of preference that you want to do. So that basically is just modules in Motoko. Right here, and I have listed how to install Vessel. So I will share the presentation in the Motoko Bootcamp organization, so you have access to these steps. But this is how you, since there aren't good explanation on the Vessel page, which you can find here, on how to do this. So I would say let's do it together, how it works. So I'm going to go to the website. First, 1 second, let me remove Vessel for my system. So now it's going to say it doesn't exist. Okay. So we go to Vessel. So the easiest way is just go to releases. And right here, 20 days ago, there was the latest release of Vessel. Down here in assets, you will find for your operating system a pre-built binary. So I'm currently on Linux. There is also one for macOS. The steps you're going to follow are basically the same. So we're just going to click on it, and we're going to save the file basically, which will be probably in my downloads folder. So let's go back to the slides. We downloaded the Vessel binary for our operating system we're using. Now open a terminal and navigate to the downloads directory. So wherever your file is stored, and this we can do with the cd command, which stands for change directory. So in my case, we go to downloads, because it's located in here. Step 4 is we need to make it executable. This means basically when you download a file, your operating system is not going to deem it as an executable by default. So we're going to do that by the command chmod.x to make it executable, and then basically the name. So in my case, it's the Linux one. You can also, if the Mac OS, then the last part is going to Mac OS. And we do enter. We basically made it an executable, so the operating system knows this. You can very easily validate it by doing / and then the name version. So now it's going to execute and put out the version, but still didn't install the binary. So what I most of the time do is I basically echo my path, and your path is something your terminal will index looking for binaries and automatically discover them. So here is a lot to see in my path. For example, I have Go installed, so that's in my path. There are other ones, local bin, but basically I'm going to put them in my bin directory that I specified here. So I'm going to move it, which in our case is the Linux one, and I'm going to move it to one of the directories that is defined in my path. So I'm going to do home, quint, bin, and in here I'm going to rename it to Vessel That's basically just short for doing it. And now I moved it. So if I'm going to try the command from before, it won't work anymore since it moved to the directory I specified. Right, so step 6 says check whether it was installed correctly. So basically right now, your terminal should discover it automatically. So we can call which is asking where does it live basically, and put vessel. And now it's going to say, well, I found it in this directory here, and that's exactly the one that we specified above. So right now I can go back to my bootcamp folder and I can do vessel version. Of course, something needs to go wrong. And it puts out the version itself. So if it doesn't find it directly, just close your terminal and open it again, and it will re-index every folder basically. So let's continue the presentation itself. We have it all installed, so we're ready to go. Now, using Vessel, there are a few steps. It's pretty simple. Vessel has a command in it. So we're going to call Vessel init, and it's going to create 2 files. The first file is vessel.dhal. So don't be scared by the words dhal that you don't know. It's basically a syntax that they chose to write it in. And by default, it's going to output the following 4 lines. So let's go over them. So is calling vessel init dependent on the current working directory? Yes, it is. So you need, I will show it in the demo, you need to be in the directory you want to initialize it in. So basically, if you did vessel dfx init, it created your whole project structure. So you need to make sure you're in that directory you want to initialize it in. Okay, so the first line specifies which dependencies you rely on. So by default, it gives you base and matchers. Base is a reference to the Motoko base module of Dfinity itself, and matchers is a testing library they use. The second line, compiler, says non-text, which means at this point in time, there is no compiler specified. But we could, and for this, I added the bugs below. So for a custom Motoko version, the Motoko compiler, you can, for example, specify compiler is some. That's a dhal syntax, basically. It's like optional values in Motoko, and then you have to specify the version number. So I think the latest version of the Motoko compiler today is 0.6.25. Now, the second file it's going to create is a little bit more scary. There is a lot going on there, but I'm going to walk you through it. So first line, let upstream, and then there is a whole URL basically, which even has a hash at the end to validate it. What this is Dfinity has provided a vessel package set, which is basically just a predefined configured bundle of packages for you to use. I also have created one myself, which I will show later. So basically, this gives you a set of predefined packages in which, for example, is the base and matchers is included in this. Okay, so we have upstream, and next we have this chunk. So what this does is basically it differentiates in additions, which are packages that are not defined in the upstream. And secondly, there is override, which is if you, for example, want to use an older version that is in the upstream package set, you can override it to a custom version. Like you saw, I skipped the second line. Reason being is that it is explained right down here. So it's basically a structure in which you have to define and explain how the package R is called, which version you want to import, a reference to the repository. So it is a Git repository. I haven't tested it with something else than GitHub, but I assume it will work. And the dependencies of that package itself. So if that package depends on other stuff, you have to include it in here. And then basically the last step is we're going to combine upstream with the two others we've defined. In our case, they will be empty. And we just concatenate them together. And then Vessel knows what to do next. So I'm going to start a demo. But first, I'm going to look at some questions if there are any. Andrew said that there is indeed an open PR on install instructions. You can also look at that. Can you have multiple upstreams was a question. So if we go back, so upstream basically is just a name they gave it. You can also name it Definity, for example. And then under there, you can define, for example, I make a package set for Aviate Labs. You can say let Aviate is and then the other package, and you just can combine them with the concatenation like below here. So yes, it is possible to have multiple. So let's try and do something and use a package. So I have about 30 Motoko packages written already. And this is, for example, is my package set. So you can also import it the same way as the Definity one does. So basically here upstream, it is a different one than the Definity one. So you can just rename it to whatever you want. But we are going to use a pretty simple package, which extends the array capabilities of the base package. So we're going to use Vessel. So if you look at the right side of my open terminal, I'm in a directory called Bootcamp. And maybe just open VS Code, it will be simpler to work in. If it wants to at least. Let me check. So right here, we have Bootcamp opened. I hope it's readable. Let me quickly increase the font size. So it should be 20, which should be plenty. So in the terminal beneath, I will do Vessel init like we saw in the slides. So it created here on the left two files. So like we can see here, one is indeed the dependencies compiler none, and the other one is a very big file with the upstream additions, etc. Right, so let's create a file, main.mo. And in here, let's say we want to create some kind of module. Well, Vessel allows you to install a certain version of compiler for you. So for example, if we want to use the latest compiler, since the DFX SDK sometimes is a little behind, we can specify it in here and use it. So right now it's going to get a little advanced how things work, and it can be daunting in the terminal, but basically Motoko comes with an interpreter, and what an interpreter does is it basically tries to mimic the code, how it would be run, and checks things. So Vessel allows you to use the version of compiler you've specified, and it has a flag called check. And for this, we're going to pass in also the sources that we specified in the package set itself. And then we can specify that we want the main.mo file checked. So right now it's going to install stuff. Like you saw, it installed 2 packages for its base and matchers, since we defined this in Vessel. For example, if you don't need matchers, you can just leave it out here. And if we then remove this again and just do it again, it's going to install 1 package named base. So it's created a .vessel in here. And right here, we can see it imported base. And this is the whole base package, basically, that Dfinity provides us. But if we open array, there is a lot of stuff here, but not enough. For this, for example, I extended the array package for Motoko with some additional functions. And if we go look, the first one, for example, is the function contains. So let's say we want to import that function and don't want to write it ourselves. So I would think, okay, I want the array package, right? So I'm going to run it. But now it says, well, array doesn't exist yet. So we still have to define it in the package set. A question was, so Vessel is like NPM? Yes, you can compare it to NPM, but it's a lot more manual and a lot more difficult than NPM. So you still have to define where you want to get everything yourself. So we want, by the way, this all is a comment in dhall. So I'm going to remove it for now to keep things simple. Overrides we don't need, since we are happy with the versions they provide. So we all only want to do some additions, so things that are not in the upstream package itself. So in here, in the array, we basically want to specify the following: the name of the package. In our case, this name should be the same as this name. I can call it A, but then here I also need to call it A. But to be complete, let's call it just array. And the version, if we look at the latest version I put out, is version 0.2.0. Okay, fine. And then the repository, we can just copy paste the URL right here, put it here. Dependencies, well, there is one. It depends on base. So we're going to define it. Now let's try to run it again. Right now it says installing 2 packages. So it also downloaded array for us. And if we go and look in here, we see that there is a new package called array. And in source, indeed, we can see the same function as we saw on the left. So right now, let's use the slides again. So if we want to import an external package, we're going to say import. I want to import the array file. So here array.mo, I'm just going to call it array. And here we say mo because we want to import the Motoko package. And right here, the name of the package. So if we look back at the package set, the name was array that we defined it. And in array, I want to import the module array again. So if we try to check this again, it will still work. Great. So let's say we don't want, we want a function that checks if an array contains a 0, for example. So a function contains 0, and we're going to pass it an array of natural numbers, and it's going to return whether it contains 0 or not. So right now we can use this array package, and inside we can, of course, use contains. We're going to pass the type because we need to specify it. We can pass in the array. We want to check if it contains 0. And there is one extra thing. We need to import not from the base library, since we want to make use of the equal function on which it depends to check whether two elements in the arrays are equal. And this basically will now check whether this array returns 0. So if we're going to look at it again, it's fine, it works. So we built a package, a module that checks for whether an array contains 0. So I'm going to close this. Let's say we want to test this. So let's create a quick test directory and say 0.test.mo. And in here, we're going to make use of our new package to be, let's call it also array. Doesn't really matter what we call it basically. But right now here we can import array, our custom package, and we're going to go dot means go a directory back. So we're in test. So then we're back in the bootcamp directory. Then we want to enter source and basically import array. So I can reuse the function here, but instead of check, which you can see, we can do -r, which is going to interpret the file. And then we can do test and then the 0 test, for example. And this at this point in time does nothing. But now we can test our function. So let's create that array from natural numbers. And first it's going to 1, 2, 3. And we're going to check, we're going to assert that array dot contain 0 of excess. Basically, we want it to be false, right? Because indeed, there is no 0 in there. So if we run it again, it says, well, there is a module there, but the field contains 0 doesn't exist. So now we're going to look back at what I said about field types. In here, by default, this is a private function. So we need to specify that we want to export it to public. And right now, if we run this again, it worked perfectly fine. And this assert also passed since it doesn't give an error. So if we're going to set it to true, it's going to say, well, no, we have an execution error and assertion failure, which is indeed the case on line number 5, which is here. Now, the other case, we can also assert that the array 0 contains 0, which is a little bit silly, but this one should be true, right? And indeed, it was true. So this basically wraps it up, which means we imported an external package through Vessel, and we imported then this local module then again into our test files. Now we can open source this, and now others can import this function into their package the same way we did it with this package basically. So let's open up the slides. I don't think there's anything else I want to say. Yeah, I got 2 links. One is to the Vessel, and there is another on the smart contract docs. Basically, there is a whole section about modules and imports, which I recommend you read. There is some interesting stuff there, but basically I got everything covered you should need to know to get started with it. And this is the last slide. So the Q&A. Yeah, this is the end. So feel free to ask any questions. I'm going to go to the chat right now and see if I missed anything during the talk itself. Let me see. Is the DL VS Code extension the same thing? The DL VS Code extension only provides syntax highlighting, so it has nothing to do with Vessel itself. It's only a utility to make things prettier, basically. What is the command used to build/generate the dependencies? So Vessel will do this for you. So whenever you're executing a function like Vessel sources, it will list for you all the sources there are. It will download it if they aren't downloaded already. So there is no generate command. It happens under the hood, basically. I figured it out after breaking down the modules in the base directory. Yeah, so looking at the base modules, it's a good thing. It's a good reference, basically, how they do things. So they're doing the same thing. They have a source folder and a test folder, and they import it the same way I just showed you guys. So, so how do you open it for open source? So, for example, this directory right here, the only thing I should add a README for others, of course, and stuff like that. But except from this, you can just put it on GitHub. And since they can specify the URL themselves, it's ready to go. So as long as you follow the folder structure, you shouldn't have a problem. There was a question, which is a pretty advanced one. What's the difference when we use DFX cache instead of Vessel bin? So DFX comes packaged with a specific Motoko compiler. So I think in 9.2, the latest DFX version to date, it is Motoko version 6.22, I think. So you're basically stuck with it if you use that one. So if you want to make use of later additions to the language, you can use it. through Vessel basically to download it automatically, so you don't have to. So the main difference is that DFX, you can use that one if you want to use it, and if you want to use a specific version that's not packaged with DFX itself, you can use Vessel. I like to use Vessel since then it's documented in code which version you used and you developed on. But it basically doesn't matter. It's just your own preferences. If you had added all Aviate Labs modules after the base modules, how would the imports work? It doesn't matter. The order doesn't matter, basically. So you can define them in whatever order you want. There was another question. What's the importance of using Vessel? So when can we import directly from Motoko? Is there any special thing in it? Please, I'm curious. So you do not have to use Vessel. So if you only want to use the base module, that one is packaged within DFX itself. So you don't need Vessel for that. But if you want to rely on other packages that other people have written, utility function, or for example, SHA-256, for example, I've written a package for that doesn't exist in the base module. You kind of have to import it some way, and Vessel provides you a relatively easy way to do it. So the specialty is there. It manages the packages for you, and you don't have to do it yourself and download them. It does it for you. So that basically is the power of Vessel. So yeah, it's on your you can write Motoko packages without it, basically. It's just a tool to make it easier. Are there any other questions? That asks, so ext is not a module. Not sure what you mean by that. So the Tonic Labs ext on GitHub. Not sure how that one looks. I think it's here. This one is not a module. You're correct, since it's not a source. So you won't be able to download it, basically. But I think Jürgen has a version that you can download. No, this way I make a fork myself. Let's see. So he made a fork and he renamed it to source. So basically this is a version that works with packages. Another question was, does Vessel works with Rust libraries? No. So Vessel is a package manager for Motoko specifically. So for Rust, you will have to use Cargo and do it that way. So Vessel is for Motoko specifically. All right, any final questions? or remarks, whatever. How was the beer? Yeah, I'm drinking a beer. Some context, I'm from Belgium, and in Belgium we drink a lot of beer, and I like it. I enjoyed the beer. It's thank you. It's evening, so um, I was looking out for it for a whole week. 5% is a light beer. Yes, I think it's even less. This one, it is 4.6. No, 5.2. So it's indeed it's a light Belgian beer. Um, can we also import modules that are deployed on the IC? You can. I recommend you go to the documentation on Dfinity themselves. It is quite complicated to do since you need the interface specification and you need a WASM module of whatever is deployed. So it's quite limited what you can do. But it is possible to import like canister references, for example, actors that are running on the IC. An off-topic question, can you call a query from within the same canister? You can, but I would recommend just creating a private function and call it that way. Then you don't have the delay. A question I didn't see when you installed Vessel, you only moved it to your path. Does that mean it's installed or I'm missing something? Yeah, let me go back to where I did this. So these are the steps. So basically what I did is I downloaded it from GitHub from the releases page. There you can find a binary in the asset dropdown. And then I made it an executable like step 4. And then I indeed moved it to my path, which makes it installed basically. Yeah, this is some Unix stuff, but should be pretty straightforward. And if there are any questions, feel free to message me. If we're running WSL2 on Windows, yeah, so basically, if you do use WSL, you are using Linux. So you need to install the Linux binary on there. How to install on Mac? These steps are exactly the same for Mac, except from your path here is going to be a little different. But for Mac, there is an open PR on the Vessel package itself, which you can from Gabriel. Off-topic question again. There are so many teams building different token standards. How do you see this playing out? And what about interoperability with these standards? Very good question. I can talk about that for hours, but I keep it short. I think it's good that people are experimenting. For example, right now, the EXT standard of Tonic Labs is pretty dominant since they have the only, or let's say the biggest marketplace on the IC. But in the future, we will see others. So we'll probably see the dip standard of Psychedelic, for example, is another big one. But I think organically we will have a winner in the end. But it's good that we are experimenting with different standards. We need to have an open conversation and experimenting with it. It's nice. Interoperability, it's a problem we should solve, but I think that will sort itself out. So yeah, that's on token standards on the IC, but I assume there is even another talk for this that covers this. So are there any other questions about Vessel or Motoko packages? All right, I think this is it. I would say enjoy learning things, enjoy experimenting on the IC. It's the best way to learn. And I probably will see you in the chat somewhere in the future or other Dfinity related meetings. Yeah, good luck. I'm going to stop sharing my screen.
All right, guys, see you in 1 hour for the talk on variants. Thank you, Quint.
Bye, everyone.